Welcome to aminacademy.com. In statistics, let us discuss about linear relationship between variables. Look at this figure. Here, it's XY plane. Some points are plotted regarding the given data. A linear relationship or linear association is a statistical term used to describe a straight line relationship between two variables. Linear relationship can be expressed either in a graphical format or as mathematical equation of the form y equal to mx plus b. Here, this is a graphical form. Here, for x, suppose x is 20, for that y is here somewhat 53, like each points represent linear relationship between x and y. So this complete points represent linear relationship. We can draw a line through these points. That's a straight line linear relationship. The linear relationship between two variables. Look at the equation. Y equal to mx plus b is a linear relationship between variable x and y. In this formula, m denotes the slope of the line. At the same time, b is the y-intercept, means where the line cut in y-axis, that is y-intercept, or the point on the graph crossing the y-axis with the x-coordinates being 0. If the value of m and x and b are given, one can easily get the value of y. That means you have to substitute this m and b values in and x values in this equation. You can get the value of corresponding y. One can graphically plot the same to show the linear relationship. So look at here. This is, suppose this x-axis. Here, this y-axis. This line now represents is y equal mx plus b. The following table gives examples of the kinds of pairs of variables which could be of interest from the statistical point of view. This is x description for y description. Here, predictor or independent variable. This x is called a predictor or independent variable. Y is a response or dependent variable. So whereas x changes, regarding that the value of y also changes. Now for example, temperature in degree Celsius, temperature in degree Fahrenheit. Suppose x changes. If temperature of degrees changes, regarding the relations for y also changes linearly. Area of the house in square meter, suppose. Value of the house. Suppose area is big, square meter, that is value of the house also big. And even if it becomes small, lesser, the area of the house become lesser, the value also become lesser. Age of a particular make and model of the car, resale value of the car. Suppose car is new, newer, that resale value also new. That is called the car become older and older, the resale value also become lower. Amount spent by business on advertising in a year, revenue received that year. That means if you give more advertisement in well manner, we'll get the revenue will be higher for the business. These are some examples for direct relations between two variables. Now, here, look at this. Suppose this is x and y relation. Y equal 9 by 5 x plus 32. It is a relationship between degree Celsius and Fahrenheit. Suppose we plot the values x and y. We get this. Suppose these relations. This is a relations between Celsius and Fahrenheit temperature pairs. Here we'll draw a line passing through all points like Here this line represents a straight line for the relationship between Celsius and Fahrenheit. These are direct relations. The relationship between x and y in the temperature example is deterministic because once the value x is known, the value y is completely determined. That means once value x is known, for that regarding y value we can understand. This is x value where it hits the line and comes to horizontal line, it gives the y value. That is called a deterministic scatter diagram or scatter plot. Looking at the plot, it is evident that there exists a linear relationship between height x and weight y, but not a perfect one. The point appears to be following a line, but not exactly. There is an element randomness present here. Previously, this line matches that touch all the points, but here it is not exactly related to the straight line, so it is have some randomness. This is called a scatter plot. That means each and every point, that is for x particular x point, there is a y value. For x point, y value, like it is related but not perfect relation. The level of randomness will vary from situation to situation. In the introductory example, connecting an electric current and the level of carbon monoxide in air, the relationship is almost perfect. In other situations, suppose such as the height and weight of individuals, the connection between the two variables involves the high degree of randomness. That means whoever more height, we cannot predict he is more weight. So there is a high randomness is there because we cannot predict a linear relationship between some population, some peoples together. Is not a linear relationship between their height and their weight. Another, the two variables x and y have a deterministic relationship if points plotted xy pairs is directly along a single straight line. That means if all points plotted in a graph, if we join all points, it becomes a straight line, then we can say it is a direct deterministic linear relationship. In practice, it is common for two variables to exhibit a relationship that is close to linear but which contains an element, possibly large, of randomness. A line has the equation y equal 0.5x plus 2. Suppose it's an equation is given, pick 5 distinct x values, use the equation to compute the corresponding y values. Look at here. Here this relationship is y equal 0.5x plus 2. Now suppose give x values here, y values regarding that. Put x is 0, but x is 0 means y is 0 into 0.50 plus 2, this 2. X is 3, y is 3 into 0.5 is 1.5 plus 2 is 3.5. Like x is 8. Here x is 8 means 0.5 plus into 8 is 4 into 2 is 6. Then x is suppose minus 3. Minus 3 means here x is 0.5 minus is minus 0.1.5 plus 2 is 0.5. Like x is 10, y is 0.5 into 10 is 5 plus 2 is 7. So this is the 2 points we calculated for x and y, which is related regarding this equation. Now next example, give the value of the slope of the line which gives the value y equal to, suppose this y here y equal to x minus 0.5. First they are asking the value of slope. Slope is nothing but the coefficient of x. Slope is your 1 because 1x, y equal to 1x minus 0.5. That y intercept, that is b intercept, you can say as y intercept, which is equal this constant value minus 0.5. Now, so far we have done some examples regarding a line, equation of the line, and as well as we plot some scatter diagram and linear line, that is a relationship between two data with linear relationship. Further it is, for example, here. Now further we discussed about the relationship between linear relationship between two variables, that is equation is y equal to mx plus b. We have done. Please subscribe our YouTube channel.